and thank you for joining today. For those of you who are not part of our regular newborn screening work group, in the Heartland region, our newborn screening work group typically meets once per month, and on I think the fourth Wednesday of the month or something like that, and we bumped it up a week because of the holidays, but we are devoting our meeting today to a webinar. Our guest speaker is Dr. Christopher Swearingen. He was a developer of the Arkansas Long-Term Follow-Up database, and we invited him to talk about that database. Although Heartland had no financial sponsoring of the database, since long-term follow-up is an important topic for all of our states and of interest to our states, we thought maybe we could share with others in more detail than I believe has been shared previously how Arkansas created their database, what it contains, and how they're using the information. So without further ado, I'll turn it over to Dr. Swearingen, and then at the end, if there's time, we will have another topic to announce by Dr. Amy Brower. Also, I want folks to know that you are muted right now. That's to improve the quality of the sound quality of Dr. Swearingen's presentation. We are recording this for archival purposes. And if you have questions that you need to ask during his presentation, please type them in. And Dustin Foster will be monitoring those questions. Dr. Swearingen has allowed time in his presentation to take questions at the end of his talk. Okay, I believe those are all the housekeeping items. Dr. Swearingen, I'll turn it over to you.
Great, thank you very much. I appreciate it.
Mm-hmm.
I just appreciate the opportunity. I also appreciate that there is a lot of interest in the work that we've done, and the way that I'm presenting this information today, I hope isn't too technical. There will be some jargon, but I'm going to try to define it as I use it so that we can really express what we're doing here in Arkansas. Just by way of Dustin, oh, there we go. Sorry about that. All right, so just by way of disclosures, I am currently funded through both contract under ANGELS, UAMS ANGELS, which is in partnership with the Arkansas Department of Human Services, as well as the Translational Research Institute here at UAMS. Both of these have supported both the development of the database as well as our work here and my salary. So just some of the objectives that were briefly mentioned by Lori. I'm just going to be providing a general overview of the Arkansas Newborn Screening Long-Term Follow-Up Database. I'm going to be discussing the framework that we use to develop the database, as well as the development process on some of our case report forms that are used to abstract the data, as well as the development of the data dictionary. I'm going to conclude with also some of the lessons learned, as well as some of the results that we have to date on what we've been doing. Just by personal background, I received my PhD just a few years ago from the Medical University of South Carolina. However, I was involved in research for the last 15 years, and a lot of that has been collaborative in nature, but a lot of it has also been with research informatics in mind. In fact, I actually dealt with a piece of software that was not Y2K compliant, in which we had about 15 to 20 years worth of data serially collected on patients, and as of December 1999, you have patients with encounters up to 100 different visits recorded, and then come January of 2000, that first visit in January would be listed as their first visit ever. And so really the Y2K bug really pushed me into this whole realm of research informatics and how to really capture data in such a way that we can translate what goes on in a clinical world and try to bring some research inference and from that. Just a brief history of Arkansas newborn screening. During the early 2000s, Arkansas really only screened for these 7 conditions. As I understand it, as has been the case throughout the last few years, a lot of different states have begun to expand, and as of July of 2008, Arkansas joined one of those groups, is expanding their screening to include all 29 recommended primary core panel conditions. And I've listed here for purposes the actual PDF listing on the Department of Health website for all of the conditions that we screen. And it was really a lot of this that then spurred our development for long-term follow-up. As I have heard our director, Dr. Schaefer, speak many times on how genetic screening really started, I'm fascinated by the fact that it really started out of a singular disease and really a singular effort to just try to change the outcomes of specific patients. And so here, his philosophy and mantra is the same. We don't know what we're going to be able to collect on these patients, but we want to collect as much information as we can in order to make sure that we can then begin to understand and hopefully change their outcomes for the better. So with that, in 2009, we began actually developing data definitions for the long-term follow-up database. We first broke this down by using both common data elements, and we defined those as things that would be available as well as necessary for measurement across all of our newborn screening conditions. But then we also divided into each condition, we divided specific data elements that were going to be specific for that condition. And with those definitions in hand, in the summer of 2010, we began construction on our REDCap database. I'm a little fuzzy on when we started that because our REDCap database development was kind of spurned by our understanding of what REDCap could do, as well as who was controlling it and how that was being done. So speaking first on the data definition development, our long-term follow-up database is based upon a premise that we're actually going to be abstracting medical record data for research purposes. Since Arkansas Children's Hospital is really the only specialty care hospital in the state, 90 to 95% of all kids with a newborn screening condition will be followed here. And as such, the best way to capture all information on all of these kids is to simply abstract the clinical record. Instead of asking them as well as their parents to consent to a study, we received IRB approval to just abstract that data so that just so that no one would be able to opt out, and we would lose possibly the only case that year of a particular condition. So that being said, the challenges that include and setting up these data definitions are really the fact that clinical data are inconsistently recorded. Depending on whether or not you have a resident or an attending physician or a seasoned professor recording the data, you're going to see different levels of how the data is recorded. Moreover, just personal preference is going to change certain things. Some of the definitions that we had to battle and are continuing to clean include simply the age at which something is recorded. In a developmental history, you may see a developmental milestone recorded as 18 months or 1.5 years, or 3 months ago. And the argument that we have to bring to that data is to convert it into a meaningful metric that is consistent across all of our patients. More importantly, though, not only is it really inconsistent recording, but the problem is that we are trying to categorize data without a complete listing of all possible entries. Medications are always changing. The actual information that we're collecting is always changing. And to try to actually create a rigid list of things that you can check or to mark off without having a complete listing of all possible entries is a very large challenge. However, once we defined what at least initial draft of our definitions, we began to program our REDCap database. Now, you may ask, what is REDCap? REDCap stands for Research Electronic Data Capture. This is a web-based database system that was developed at Vanderbilt University and has continued to be supported at Vanderbilt University. The great thing about REDCap is that it has a lot of inherent tools that are capable of meeting a lot of the stringent criteria for federally regulated studies. In specific, there is a Code of Federal Regulation that is often referred to as Part 21 compliance, that deals with electronic data capture devices for clinical trials. REDCap has the tools that could allow you to certify this as an electronic data capture tool. Technically speaking, this is a lot of programming that sits over a SQL-based server. And so the great thing about that is that we're now no longer just capturing data in a simple Excel spreadsheet. There is a structure to the server. That server is backed up, and we can also use REDCap to structure our data in such a way that reports and queries can come from it. So some of the other benefits of REDCap are that it is a secure system. Being that it's web-based, it allows for simultaneous data entry to occur. Our study team can have not only analysts abstracting data for reports, but we can also have simultaneous data entry going on from our data team. One of the other things that is built in are these audit trails, or also called the transaction history. We can go in and identify who is doing the data entry and when it was done, and particularly track down and solve possible entry errors. One of the other things that we can also do is restrict how data are being entered. If we want to know that one particular field is going to be a date field, we will restrict it so that it can only be a date field. If we know that a certain lab is only going to be an integer that is ranged from 1,000 to 10,000, we can set that up so that no decimal will be able to be entered, and that only values between 1,000 and 10,000 can be entered. So this just establishes really great quality control of our data. And then one of the last benefits of REDCap is that inherent in some of the programming is the fact that it will produce case report forms. And we actually, once we developed our database, we had our case report forms automatically developed. Now, some of the users inside of the user group for the REDCap consortium have actually developed some programming that also have developed a really nice code book. And so that code book is also available as a function of REDCap. So in using REDCap and considering how to use that for our long-term follow-up database, there were really two different things we had to tackle, and one was just how the projects are being set up. REDCap has inherently two different project modes. One would be a simple mode in which basically if you think of like an Excel spreadsheet, you have one row of data, and across all of those different columns are all of your variables that you're entering. But for any one particular row, all of the data summarized on that row are corresponding to one specific subject. One of the other ways that REDCap is set up is to utilize a longitudinal project system. And here, basically going back to the Excel analogy, you now have multiple rows that contain data across time for the same subject. Now, one of the issues with that is that longitudinal projects must have all of the time points defined at the start of the study. And that's really not appropriate. It may be appropriate for a clinical trial where you know you're going to have 12 visits scheduled over the next year. But when it comes to our long-term follow-up, where we're asking our database to track visits from birth all the way to age 21, I can't define rigidly how many visits are going to occur. And in fact, in some of our results, you're going to see that certain disease sets have many more visits on average than others. So this wouldn't work. We couldn't say, well, we're only going to be able to define a database with maybe 10, 20, or even 100 visits. It just won't work. The moment I set a limit is the day that one of the study team members comes to me and says, well, we now have our 101st visit. Now we have a problem. So while neither project mode is appropriate for a long-term follow-up database independently, we are able to use several projects jointly to create what we are considering a flexible and infinite long-term follow-up database. And what do I mean by that? What do I mean by that is that we actually created our common data set to be residing in the middle of all of our disease projects. And you can see by this diagram schematic, this diagram schematic places common in the middle. And the one key identifier, the study ID that is in that common database, is linked through all of the other child child projects. All of the child projects have that same unique identifier. Also added to each individual project is a date field. So whenever we go and enter a record that is going to be tracked, a new patient will be tracked in our newborn screening follow-up database, the first thing that will happen is we assign them the unique identifier. That unique identifier gets entered into the common database. All of the common data elements are entered, and then depending upon which specific disease set they're going to go into, then we enter specific visit data after selecting the unique identifier for all the different dates. Now, one of the things that is really nice about this setup is that this is a tried and true setup that is that's been developed that Microsoft SQL Server, Oracle database, a lot of these big database companies have developed and used this type of relationship system, which is technically referred to as a one-to-many relationship. And there are certain rules that can be established to enforce integrity so that you don't have multiple IDs with multiple dates, duplicate data entry across the board. Unfortunately, in REDCap doesn't have that type of integrity system set up. You could actually go into a disease-specific project without doing the subject entry into common. While that is done, the fact of the matter is, and I will be showing this visually in just a few minutes, the issue is we can always go back and we can link the record later. In fact, even when data entry errors occur or a medical record number has been entered incorrectly, we can go back in and correct that ID and then correct the linkage so everything comes out to be correct. At the same time, also you can find issues where duplicate entries are made on the same date for the same subject. And while that does happen on a rarity, our quality control queries are set up so that we can identify those types of things, review it, and that will lead to data correction as well. So moving forward, I wanted to do now really, if I could, like a little hands-on demonstration of what we do with REDCap. And so I've got a lot of screen captures here, and I'm just going to kind of walk through everything that we do and how it's done in our long-term follow-up database. So initially here, I'm going to start off with our common data set. And as you can see, there's a lot of different information going on. I'm going to start off with, on the left here, what we consider to be our data collection access widget. And this little group of data collection icons, they're all hyperlinked, so you just simply click on them. And to get to this one particular screen, I clicked on Add or Edit Demographics. After I did that and it opened up my demographics page, the next thing you're going to see is the fact that I can then open up a drop-down box and it lists all 341 of our current record IDs. And you can see here it goes from just, newborn screening ID 1 all the way currently you can see up to 17, but you would just scroll down the list to find that data. And once you would select on that, it would open up the record. Now, something else I can also do is simply click on any one of the specific data collection forms that I want to use, whether I'm maybe entering something that's in the demographics form or maybe entering something in the history form. There may be something else that I want to go to, and I want to navigate to that directly. If I were to scroll down on the screen a little bit, though, So I'm sorry, I'm going to go ahead and enter into demographics, and I want to show you exactly some of the things that we can do with the newborn screening. Right here I've snapshotted all of the entry that deals with the actual newborn screening results. And you can see here in green, this is the current field that's highlighted, and we have a checkbox for all of the newborn screening conditions that a child may have been screened positive for. Now, while in actuality, it may not be that, it's very rare for a child to have more than one, but usually, if that is the case, it's a condition plus hearing. So what I'm going to show you, though, is that whenever you click on one of these boxes, the initial setup in our database is to actually to capture some of those results. So you see here, the initial thing that I clicked on was biotinidase, and then below it, this is all logically controlled on our form. We can see the results. We can also see some specific things in terms of biotinidase drug history. If I were to select cystic fibrosis, you can now see that the biotinidase entry has disappeared, and it's been replaced with a cystic fibrosis results summary, in which we have a couple different entries. We have the results as well as whether or not the patient has actually consented to our cystic fibrosis registry, which is a separate database system that's run by our pulmonologists. If I were to click on CAH, congenital adrenal hyperplasia, again you see that our CAH results pop up. And I'm going to go ahead and move through this as well. We have this for congenital hypothyroidism. We have this for galactosemia, as well as hearing. You can now indicate whether or not it's left, right, or bilateral hearing loss. Now, the last two are some of the more complex ones. For hemoglobinopathies, there are 3 specific hemoglobinopathies that we're tracking. And then in MSMS, we actually are tracking 3 specific broad categories of MSMS, but then once you click on, say, the amino acid disorders, you'll then see which of the amino acid disorders the child may have. The same thing will hold true if you click on fatty acid or if you click on the organic selection. Now, everything that I'm showing you is all from one specific form. That one form is able to modify itself automatically based upon how you're doing the data entry. So if I go back to the beginning entry, one of the things I wanted to show was also how you could, right now we have 340 records in our common database. That's a lot to scroll through. We can actually use a search field. We can pull out, let's say I want to search for a specific ID. I can go in here, select the field I want, and begin to type it in, and it will pull out that record. Now, some of the other things that you can also do, you can see here under the applications section of our navigation board, there are a lot of different things that are available. Most users won't see a lot of this stuff, particularly the user rights or even the record locking or e-signature sections. Those are particularly useful for clinical trials, maybe not so much for the long-term follow-up database. However, graphical data view and statistics is something that is very useful and really provides both users, PIs, anyone using the system, a real quick look at what is going on currently in this data system. And so one of the things, I forgot about that too. One of the things we also have here are the project bookmarks. The bookmarks actually navigate from our common to all of the different sections, as well as the top one here is to submit a change request. And I'll be getting into that next. But what I wanted to first initially start off with was looking over just a snapshot of our current results in newborn screening results in our common database. And this is simply done automatically on the fly if I were to click on the graphical view and stats section in REDCap, where then I can list out all of the different, it automatically summarizes all the different results. And here I selected it as a pie chart only because it was the easiest thing to fit on the PowerPoint slide. But you can see at the top where we have actual frequency counts, we have 10 biotindidases, we have 25 cystic fibroses, we have 100 hemoglobinopathies, and then it actually represents all of that in our pie chart. Now, if I were to go ahead and click on that hyperlink that said submit a change request, one of the things that we developed over the course of developing this system was to also use a REDCap project that was nothing more than a survey. And that survey would be initiated by our study team to say, you know what, we've been abstracting our data, we have an issue, we need to make a change. And so here we have a simple comment box to give a short title to the change that's being requested. We can then specifically target which projects are going to be needing the change, and then a complete description of the change request. And you can see here we have two different categories. One is a project setup or kind of changing our structure or our data definitions. The next would be actually a quality control or data verification. Sometimes we'll get requests in here that say, you know, data entry error, please delete this entry, please correct this entry. All of the correction and deletion is withheld only in rights by our analyst team. All of the data entry team and abstractors cannot make the type of deletion changes that are required. The next thing that is not necessarily shown here is also below this is there's the ability to upload a PDF document, and that would actually allow for complete detail of our current case report form should a new change be required, and that can be loaded in here. And to date, we have well over 60 different changes that have been documented in the system that allow us to really go back and say, okay, why do we make a change, and why do we do this? And then at the same time, it also allows us to track what changes have been made and what changes are still in the queue to be made. So one of the things I also wanted to show was just how this long-term follow-up database really works, because it sounds good on paper, it may sound good in this presentation, but how does it truly work in terms of linking one project to the next project? So here, again, for argument's sake, let's say I clicked on the hemoglobinopathies link that's in our bookmark section of our common database, and it brought me to our new hemoglobinopathies project. Again, the setup is the same. We have our data collection application links, we have the other application links, but here we're specifically dealing with data that's specific for hemoglobinopathies. So if I were to click on this and say, let's create a new data entry field, well, I can do this in one of two ways. One, I can come in and I can select specifically one of the IDs that are here and ready for me to select, and all of these are actually being pulled straight from our common database through a bit of programming. One thing I do want to bring to your attention, though, is if you look over the IDs, you can actually see that there are now gaps. There are gaps in our IDs. Here I've highlighted the fact that within these 7, we span 21 different IDs numbers. It goes from 20, it skips to 25, then 27, and so on. And the reason for this is that the IDs 21, 22, 23, and 24 were all entered for other diseases other than a hemoglobinopathy condition. And so the code only allows you to enter IDs that have been labeled as being pertinent for that specific disease set. If we were to go into hearing, the same thing would apply. You would only see the IDs that have been identified as a positive newborn screen for hearing. If we went into biotinidase, the biotinidase list, again, we only have 7 or 10 of those. The ID list would be much shorter because of the fact that we only have those few. So once I select on this and the computer then records it, I can enter in date. I can enter in my data. I can select, okay, we're going to be doing data entry for today. Today was a follow-up, and continue on with our data entry. And once this record is saved, we can then take that and link it to the common data set, and we would have the ability to do that just because we've already labeled this record via the study ID. This one piece is the foundational and crucial point to link all of our data from the common data set to all of the disease-specific data sets. This one piece is what makes our long-term follow-up database possible. So, as I stated earlier, one of the benefits of using REDCap directly is the fact that you can actually use its own report function to generate case report forms. And here is a little snapshot of our common case report form. Again, I've gone back to just our newborn screening results. You can see that this is listed actually on page 6 of a total 12-page document for our case report forms. And what you can see here is you see the newborn screening results. They're listed in the same order, and it says simply check all that apply. Then you have the biotinidase results as well as the drug history report. Now, what cannot be done on the case report form, and one of the reasons why our case report form is 12 pages long, is the fact that as a paper form, it cannot be dynamic as the web page can. So even though this may be filled out specifically for a child with hearing, all of the biotinidase questions will still be there. All of the cystic fibrosis questions will still be there. One of our colleagues that actually is in the REDCap consortium that works at the Children's Hospital of Philadelphia did develop some very sophisticated report programming that could generate specific disease set forms. That specific application has not been implemented here. This is the stock REDCap reporting function that generates case report forms. If we were to move on, one of the other things I also stated was that we have the ability to generate data dictionary. I don't believe I defined what a data dictionary truly is, but our data dictionary, or may also be called a code book, is really just the technical summation of everything that goes into the database. And you can see here in this little snapshot, again, this is the snapshot of everything that we are using to capture newborn screening results. You can see here that in the data set, the 106th variable in the data set is this variable called newborn_results. The actual label is the newborn screening results. And then you can see here that it's a checkbox allowing for multiple checks to be done. And then you can see here that results 1 through 8 are codified based upon the order of the actual results. You can then see on field 107, newborn results biotinidase value, a very long variable name for the biotinidase results, but you can also see that it's been summarized that REDCap will only show this field if the logical constraint has been met that the newborn results of 1 has been checked, which is biotinidase. So the one great thing, again, about the automatic nature of of putting the newborn screening long-term follow-up database inside of REDCap is that we have automatic generation of both our data dictionaries and our case report forms. So some of our lessons learned. Data definitions are always subject to change. I think the running gag at some of our meetings is that we will be programming our database for many years to come, and it will still be programmed years after we're gone. You know, the change in our definitions truly is a reflection of the very lengthy process that it takes to codify a medical record, as well as there are times where something else may pop up that when we are consulting with some of our experts, that our experts say, you know, this is where the data truly that you want is stored, and we need to re-abstract some of our data. And really the summary take-home message from that lesson is just to check, recheck, and to recheck. No matter what we do, no matter how hard we try, there's always going to be something that will need to be corrected. And we kind of resign ourselves to the fact that we are, not only are we doing a long-term follow-up database to track the outcomes of our newborn screen positive children, but at the same time we're doing a long-term follow-up database construction. We really truly are always tinkering and tweaking And in that, and understanding that, that actually has helped us develop a standard operating procedure to accommodate all of these changes. And REDCap truly does allow for this kind of flexibility. Even once the project has gone live, we have the ability to program draft changes and make sure that we're moving forward in an appropriate manner with the mindset of keeping the already existing data intact and making sure that we have our data and maintaining the integrity of our data. So one of the things that we have done is that we will actually go ahead, once a new variable has been proposed and drafted, we will program that variable, and we will program that variable right on top of our existing data set. So nothing has changed with the existing data. We simply put the new variable inside of it. Now, at that point, we then generate reports to verify changes in our data, particularly if we're going to be codifying a new issue, such as our developmental milestones. We want to make sure that all of the ages are reflected correctly. Whether or not it's in months or in years, we want to make sure that all of them are reflected on the same metric. So we spend some time, our analysts spend some time programming and drafting these reports that are sent to our abstraction team for their review. And the abstraction team will then take those reports and verify it and validate it against the abstracted data, as well as possibly even the medical record. At that point, once we have signed off on the report, we will make the program's changes, submit another report back, and make sure that everything that has been stated and defined is correct. Make sure that we have the definitions correct. And then once we've done that, once we've actually moved data and created the new data variables and the data has been populated, we'll summarize the report again to make sure that we have the data correctly transferred. So again, the whole idea of check, recheck, and recheck is really embodied in that report system. And then once we've done that, our unused variables are actually segregated from the actual data in a form that we've entitled deprecated. The great thing is we turn that this form is something that we turn off, and the analyst team is the only team that has access to it. The actual data entry and abstraction team don't have access to it. And by doing this, we create a snapshot of the existing previous data that has been modified and corrected. The new ongoing data set now has a cleaner, maybe a more condensed or more accurate defined data set, but the original data set, the stuff that we had to clean, is still in the data set. It's simply segregated from the rest of the database. Some of the other lessons that we've learned is really how to exploit some of the automation processes that are inherent in REDCap. REDCap actually allows for data exportation to occur directly into statistical packages. Now, that automation usually can be done on that data exportation is usually driven by a point-and-click mechanism on the website itself, but we can actually use a programming interface to send commands from the statistical package directly into REDCap, and that command will automatically download the data into the statistical package. That all has to be, again, set up at a user rights level. There are only a few of our analysts that have that capability. And at this point, the only thing we do is exportation. While we could do importation, we do not have that functionality turned on. Once that data has been downloaded, the great thing is we can then draft a report in the statistical package. And what that allows us to do is to create a report that is generated time and again by just simply executing the statistical code, and it abstracts the data in real time. So if I create the report today, I can come back to it next week and run the report, and it will abstract all of the data based upon next week's data abstraction. So this is one of the great keys, I think, also to helping us move the process along in terms of helping our data abstraction team actually target files that they need to work with. And so a couple of the reports that we actually generate, one of the reports is an abstraction report. And here what we do, we simply, I've summarized a few of the different study IDs that you may see in a report. We have a couple of visits that occurred within the last within the last year, and now we're saying, okay, it's been some time. Who could possibly have, when was their next date scheduled, and do we need to go abstract the new data from that date? And so at the end of every month, we run this report to say, okay, go and select the date of the next visit from the record and make sure that we give this report to our abstraction team for them to go and abstract the previous month's data. Now, we've only been doing our long-term follow-up database actually only went live in 2012, but as we are rapidly approaching 2014 and being live for 2 years, we have noticed very quickly that we're running out of space with all of our paper records. So we've very recently developed an archival report where what we'll do is we'll target records that have been in existence for 2 years, and those records will then, the paper records, will be scanned electronically, stored on our database server, which is separate from our REDCap server, but it'll be stored on our file server, and then the paper copy will be shredded. That way we can maintain consistency along with our protocol without sacrificing a lot of storage space in our filing cabinet area. So just to summarize some of the results, these results actually come from our progress report that was submitted in the middle of this year. So this is really the verified, cleaned data that summarizes everything we've done in 2012. And as you can see, what's really leading the way, we have a majority of our data set is being driven by hemoglobinopathies, followed by hearing loss, as well as congenital hypothyroidism. If we were to break this down by the actual number of visits that we've abstracted, we can see we actually have 244 visits inside of hemoglobinopathies. We have only 167 hearing visits, but we have 204 congenital hypothyroid visits. And if I go back and you compare that, you can see that really our hearing loss and congenital hypothyroidism at the end of 2012 were almost identical, but you can see there's really much more of a visit burden in the congenital hypothyroidism disease subset. And in fact, if we were to look at this, you actually see, on average, the cystic fibrosis is the one that's really driving a majority of our abstraction work. And if I go back, we only had, at the end of 2012, 25 cases for cystic fibrosis. But yet, we have 176 visits, and on average, these children are having over 6 visits that are summarized in our newborn screening database up through 2012. All the other conditions are relatively stable, around 2.5 visits. Now, one of the other things we can do, because we have the actual data from their county of birth, we were able to develop a GIS map that actually quantified the positive newborn screens that existed per 100 live births. Now, this isn't necessarily a tool that's identifying any type of epidemiologic phenomenon. It's simply, these are the kids that are coming to Arkansas Children's Hospital for follow-up, whom we have abstracted. So in closing, I just wanted to thank our long-term follow-up team. This is truly a collaboration between our clinical abstraction team as well as our analyst team. The clinical abstraction team is led by Dr. Brad Schaefer and directed by Joanne Bolick. Tiffany Moore, Crystal Bland are integral as well in abstracting data and entering the data into REDCap. And then Justin Ketcher is a recent addition who helps coordinate statewide newborn screening efforts. Our statistical and analyst team is directed by Dr. Todd Nick, as well as we have a number of analysts, both Maria Melgizo and Chun-Chao Lo are the ones that really put all of the analysis and all of the statistical reports together. I primarily direct Jerry Stolniker as well, who is our go-to programmer, and he is the one who's really programmed every single variable and every single form that's in REDCap. So with that, I appreciate you all keeping your comments to yourselves, right? the advantage of having everyone on mute. But Dustin, at this point, I'm done, and I would open the floor up for questions.
Okay, I'm going to go ahead and unmute everyone. So we will have time for a question and answer.
This is Tracy in Oklahoma. This is exactly what I want. How do we get it?
Chris, are you still there?
Yes.
Hey, Joanne, are you still there?
Yes, I'm here. Tracy, this is Joanne Bolick. One of the things that we probably need to do is your programmers that you're working with probably need to get in touch with Chris, correct, Chris? And talk with you?
That's true. I'm sorry. Yeah, I had been muted and I couldn't get myself unmuted.
That's okay. But yes, they need to get in touch with you, Chris, right?
No, that's absolutely correct. And REDCap is your institution. If your institution has a REDCap server,
They do.
Okay, we can work with your admin there that administrate it and share our information. The great thing about REDCap is that the data dictionaries that REDCap uses can be exported and transported using an Excel spreadsheet. And so
Okay.
your team would know how to use those to set this all up. The hard and tricky part is the linking of the actual primary common data set to all of the child projects. But this is something that actually, given our code, they would be able to follow relatively straightforward, and we should be able to really aid them in that.
Okay. I will see if I can talk them into it because this was very impressive. Thank you.
Oh, thank you.
Anyone have any other questions for Chris at the moment?
One thing I wanted to also say is if your institution does not have a REDCap server, hello, if you don't have access to a REDCap server, one that we may be able to work out is some sort of agreement where we could help host the REDCap server. Because REDCap is web-based, you can actually access it as long as you have a secure web connection. So we do have multiple sites logging in and entering data from across the nation. And so truly, if that might be a rate limiting step, we would be more than happy to also discuss that with you, because I think the important aspect here is the fact that we are collecting or trying to collect the data. that is viewed to be pertinent and important for long-term follow-up research. So I just want to throw that out there as well.
I think Lori's trying to get on, but she's having a few audio difficulties. Does anyone else have anything for Chris or Joanne?
I want to thank Lori and Heartland for giving us the opportunity to for hosting this webinar and for giving us the opportunity to share information about our database. We really appreciate Heartland doing that.
Hearing no more questions, I'm going to go ahead and stop the recording. But this broadcast will still be on, so we can discuss the other